Hi everyone, in this video I'll show you how to build a network-wide ad blocker using Raspberry Pi. So I'm using Raspberry Pi 5 because that's what I had. I bought this so I can work on other project as well. So this is my first project. So without any further ado, let's get started. I recently bought the iRaspTech Raspberry Pi 5 kit from Amazon. So let's unbox it. I think this is a good starter kit for anyone starting out like me. Not sponsored though. First we have the Raspberry Pi 5 board with 4 gigabits of RAM. It's a very powerful machine. Next we have the red and white case from iRaspTech. You get nice ventilation while protecting the board. We also get an active cooler with small fan and metal heatsink. You can also see the blue thermal pad behind. You should not remove them. We also get a 64GB micro SD card with Raspberry Pi OS pre-installed and a card reader. The kit also includes two micro HDMI to HDMI cable. They can be useful if you want to use your Pi as a desktop computer. Finally, we have the iRaspTech 27-watt USB-C power supply. So basically that gives us the Raspberry Pi, the active cooler, micro SD card, the card reader, the case, the two HDMI cables and the power supply. Now let's start assembling the kit. First, I'm installing the active cooler on the Pi board. These blue thermal pads need to make appropriate contact with each component. We also need to remove this small covering in the fan connector. Now let's connect the fan cable to the fan connector. This allows the Raspberry Pi OS to control the fan speed depending on the required temperature. The cooler is held in place with these two push pins. You need to align the pins on top of the mounting holes and then press it to fix it to the board. Once both pins are in, you can check if the cooler is locked into the board and it doesn't move. Do not push the pins at an angle, just check them if it's aligned properly. Once the cooler is done, it's time for us to place the board inside the case. To open the case, you need to gently slide down the white part. You can see the 4 screw holes on the bottom red part. So align the screw holes and place the board inside the case. Make sure the ports are all aligned. The kit comes with 4 small screws and a Phillips screwdriver. This part was a little more difficult than I expected, as the screws are very small and keeping them aligned can be a little tricky. It took me a proper 4 to 5 minutes to get this done. Once the board is secured, we put back the white covering. It is pretty much assembled now. I'm just checking all the sides to make sure the ports are all aligned and everything looks good. Finally, don't forget to put these 4 anti-slip pads at the bottom. They also call them rubber feet. Just align them properly in their position and press each of them firmly so they stay attached. Although the SD card comes with Raspberry Pi OS pre-installed, I'll still flash the SD card and do it all over again. This makes the tutorial useful for other viewers as well. This is where the memory card goes, by the way, but I'm not inserting it now. And finally, this is the Type-C port for the power adapter. So before we turn this on, let's go ahead and flash the SD card. We take the card reader and slide in the SD card into the card reader and then connect it to the MacBook. So we are in the PC and you can see the card reader here as bootfs. Now let's go ahead and download the Raspberry Pi imager for macOS. We navigate to raspberrypi.com and head under software and click on download for macOS. Once the download is done, open the installer and install the application. Then we open the Raspberry Pi imager. You do not need to format the card manually. The Raspberry Pi imager will erase the card and create the appropriate partition automatically. So first we select the device. For me it's Raspberry Pi 5. For operating system, pick the Raspberry Pi OS 64-bit. For storage, our bootfs micro SD card is already pre-selected. Just make sure that's the correct storage device. Then some personal customization, we enter the host name. So for me, I'll put it Pi 5. Then select location for time zone and keyboard layout. So I'll pick Canada, then next. So username, so I'll put my name. Password, I'll set up a strong password. Then enter your home Wi-Fi name and the password to connect to it. For remote access, we enable SSH. That will allow us to remotely access the Pi. And for authentication mechanism, we select use password because that's relatively straightforward and easy, I would say. Finally, the Raspberry Pi Connect is an optional service. It allows you to access the Pi remotely from a browser. I'm just leaving it disabled for this project. Then we review all the selections we made. Then click right. Wait for a few seconds and click I understand. So the imager is now erasing the card, then it will install the Raspberry Pi OS, and it will also apply all the setting we just configured. This will take some few minutes, so I'll skip ahead. And we are done. So you can see it says the SD card was ejected automatically. So now I'll remove the SD card from the card reader and put it into the Raspberry Pi. Alright, so the Raspberry Pi is powered on, so it's been sitting there for a while. So now I'll head on to the terminal and let's connect to it remotely through SSH. I haven't connected the Pi to my PC. So type in SSH space the host name. So for me it's unique limbo at and the Pi name. So I kept pi5.local. The .local tells my Mac to look for that device on my local home network. Because this is my first time connecting, so the SSH asks me whether I trust this device. So I type yes and press enter. Then I'll enter my password and press enter again. And there we go. When I see my Raspberry Pi username, I can confirm that I am successfully connected to it. Let me check the host name. This is sample command. So the first thing I want to do is update everything to the latest version before installing Pi-hole. The sudo is for administrator permission, and the apt update, it checks for all the available update, and the sudo apt full upgrade, it installs all of them and handles any required like dependencies, and the -y at the end automatically confirms the installation. This will take few minutes, so I'll just skip ahead. So once the updates are complete, I'll restart the Pi using sudo reboot. So the reboot will apply all the updates properly and gives the Pi a fresh start. So while the Pi is rebooting, let me head on to my router setting page at 192.168.2.1. So this address varies according to manufacturer. So commonly you can find it on 0.1 or 1.1 or 2.1. I'm using Bell and for me it's 2.1. So let me head to my devices. So first I need to log in. After logging in, we can see Pi5 as one of the devices. Select the Pi5 and we'll change the IP type to reserved. So the IP address 192.168.2.66 is reserved for this Pi. Then let's save it and we'll head on to the terminal now. After the reboot, let's connect back to the Pi now. First, let's confirm if we have the same IP that we reserved for this Pi. And you can see the IP address is correct. Now let's install Pi-hole. I'm using the official installation command from the Pi-hole website. So the curl downloads the installer, and this -ssl keeps the terminal tidy, like it still shows any errors and flow redirects, but it removes the progress bar and everything. And this pipe bash passes everything to bash, which then runs the installer and opens the Pi-hole setup wizard. So the command is executed and it is installing Pi-hole in the Raspberry Pi. So you can see the Pi-hole setup wizard opened automatically. So just press OK on this and OK on this one as well. It's open source software. And for the static IP, we already did that. So we reserved the IP for the Pi-hole. So we can just press continue here. So now we need to choose how the Pi is connected to the network. So since I'm using Wi-Fi, I'll select WLAN 0. But if your Pi is connected through an Ethernet cable, you have to select ETH0 instead. So now we need to choose an upstream DNS provider. The Pi-hole handles the filtering, but it still needs another DNS service to resolve the requests that are allowed. So I'm choosing Google DNS, but you can select any other provider if you prefer. Next, the Pi-hole asks whether I want to add its suggested block list. So this is simply a collection of domains which are commonly associated with advertising or tracking. So the Pi-hole provides this Stephen Black's unified host list. So I'll just select yes to add that. This gives me a solid starting point and I can always manage or add more lists later on from the dashboard. I'm also going to enable query logging. So this will allow me to see which domains are being requested, and it also helps me confirm that the Pi-hole is working properly. For the privacy setting, I'll select show everything since this is my own home network and I'm just trying an experiment. This will also provide me useful information about what devices are making what kind of requests and what the Pi-hole is actually blocking. And I can also change this later on. With this, the installation is now complete. It will download all the required packages, install the DNS service, and also prepare the block list. This can take few minutes, so I'll just let it finish. So the installation is done. Now let's set up a new password for the Pi-hole dashboard. Once the password is done, let's open up the admin dashboard. So we enter 192.168.2.66/admin. So the IP address of our Pi/admin, and then we enter the password that we just set. Now we are logged in the admin dashboard. Let's head into settings and open the DHCP section. So the Pi-hole is already working as a DNS server, but our services don't know they should use it. So DHCP normally gives each device its own network information, including which DNS server to use. So by enabling it here, Pi-hole will automatically tell every device to send its DNS request to its IP address. So first, let's set the address range from 192.168.2.100 to 192.168.2.250 and enter the router's address 192.168.2.1, and let's enter the subnet mask as well, and then hit save and apply. Now that the DHCP is enabled in Pi-hole, let's return to the router setting, and from there we have to turn off the DHCP for the router because we only want one DHCP server running in our network, or else the devices connecting to it could receive conflicting network information. So for my home network, the Bell router will still provide us internet, but the job of handing out local IP addresses and network settings moves over to Pi-hole. Now that everything is set up, let me turn off my Wi-Fi and reconnect. So this forces it to request fresh network settings from the Pi-hole. Now let's confirm that if Pi-hole is actually working and handling everything behind the scenes. I'll use this command to get all the required information. So you can see here my MacBook received 192.168.2.186, so which falls inside the DHCP range we had configured. The server identifier is 2.66, which is correct. That's the address of our Raspberry Pi, and the router address is still 2.1, so the Bell home router is still providing us internet. So we can confirm that the Pi-hole is fully configured. Also, when I return to the Pi-hole dashboard after a while, we can see the query numbers increasing. The query log shows requests coming from my devices and which ones are allowed and which ones are not. Pi-hole won't block every type of advertisement, including most of the YouTube ads as well, but it can block many advertisement and tracking domains across the entire network. I just did a basic setup for my tutorial, but you have plenty of room for customization. You can add a carefully selected block list and create custom blocking rules, and even apply different settings to specific devices. So the Pi-hole is a very powerful foundation, and it becomes more useful if you combine it with the right tools. I have future plans of creating other various Raspberry Pi projects. So if you found this video helpful, let me know what other projects should I work on. And that's it for the setup. If you found this video helpful, leave a like, subscribe, and I'll see you on the next one.